Thank you for watching this talk. For the next 15 minutes, I'd like to share a project we're calling Multi-Level Linguistic Alignment in a Virtual Collaborative Problem-Solving Task. So much of what influences this work comes from an overarching question of how do we think through each other? And so by this, I simply mean how do other people via conversation and interpersonal interaction serve as a condition for me having certain thoughts and behaviors? So rather than two individuals whose cognition is separate, cognition is extended to the system as a network of interdependencies and continual influence. And while there are many frameworks for potentially tackling this question, in the realm of language and social interaction, one of the more compelling accounts still remains Pickering and Garrett's interactive linguistic alignment model. Here, simply in some conversational interaction, where people have to work together to achieve some goal, be it in a game or just shooting the breeze, mental representations become aligned. And this alignment is marked and facilitated by lower level linguistic levels that also become more aligned within and across people. And people are continuously influencing each other without being aware of it. One way this alignment might come about, at least in part, is via a priming mechanism, which taps into automatic and cognitively efficient processes. And there's a lot of evidence that people spontaneously adopt similar syntactic, lexical, and prosodic features of their conversational partners across conversational turns. And of course, there are other related accounts that expect linguistic alignment without a commitment to priming. But in all accounts, it's generally taken that alignment is a result of and a resource for greater shared understanding. So the study of linguistic alignment raises quite a few interesting questions that are still very much open and relevant. So for example, thinking of the mechanisms of alignment is non-trivial. Is it just priming? How much is driven by the pursuit of common ground? What about prediction? Thinking of the function of alignment is also non-trivial. So one interesting issue is whether the function varies for different types of linguistic channels. And measuring alignment is non-trivial. So what are the useful units of measurement, the scale? How do we go about addressing changes over time? So to get at these issues in a systematic way, we really need standards to be able to compare across studies. Tools that avoid common pitfalls in studying alignment, something that's easy but rigorous. And it's for this reason that with very talented colleagues, we recently developed a standalone Python package called Align, which is an acronym, Analyzing Linguistic Interactions with Generalizable Techniques. So this NLP tool is open source and available on my GitHub page, where you'll also find extensive tutorials. It's all open source, it's all transparent. It has a lot of features, but primarily it computes the amount of repetition of lexical and syntactic n-grams across conversational turns. And it employs a novel method for computing semantic alignment. So just for the briefest of introductions on how things are computed, just to orient you, for lexical alignment, you might have, say, two conversational turns within a larger dialogue. And a line begins by tokenizing and lemmatizing the content. It then creates n-gram representations. The standard is unigrams, but you also use bigrams if you like. And it then generates a frequency count of the occurrences of lexical n-grams. It vectorizes the utterances and compares across utterance turns with a cosine similarity score, with scores approaching 1 indicating perfect alignment. So for syntactic alignment, the syntactic alignment function makes use of the pen tagger, the Stanford tagger, to assign part-of-speech tags to the tokenized and lemmatized items in each utterance. These taggers are trained models that make a best guess at the part of speech of each word given knowledge of neighboring words and word probabilities. Then a similar logic as with lexical alignment, again two conversational turns, they're converted into part of speech tags, then the generation of frequency counts of syntactic n-grams, here bigrams, then a vectorization of the utterances, and a cosine score also generated. So for a simple pipeline, you start with a transcription like so, you run it through a line, and it outputs a formatted data sheet that preserves order information of when turns are spoken, direction of who is aligning to whom, and a quantification of multiple linguistic features. So when first testing this tool out, we applied it to a set of conversations from a study we had conducted involving deception. And what is important here is that people spoke for 10 minutes trying to convince each other on their opinions about a number of controversial topics. And sometimes they agreed, sometimes they did not, sometimes they were lying, but in general they tended to converge in their opinions over time. And what I at least expected to be revealed was greater alignment as conversations unfolded. But that's not what was found. lexical alignment went down over time, even though the participants appeared to converge on a shared understanding. It was not what I was expecting, given my understanding at the time of the relationship between converging mental representations and lexical repetition. And as it turns out, with a deeper exploration of the literature, this divergence in alignment we were finding was not particularly strange. In fact, in many cases, it might be expected. But why then the strong relationship between greater linguistic alignment and convergence of mental representations in other studies? So one argument is that in many tasks, the need for alignment and convergence is overly emphasized through task demands. So be it with strict turn-taking, the use of simple reference, or conversational partners starting a task with a high degree of asymmetric knowledge where common ground needs to be accumulated to succeed. However, as others have observed, in more complex problem-solving scenarios, dialogue often breaks from convergence and takes on a complementary, divergent process involving contrasting views, elaborations, and updating of prior meanings across turns. So Joanna Razachek-Leonardi and other researchers like Riccardo Fusaroli suggest a conceptual extension that calls on researchers to consider the interplay and trade-offs, or in their terminology, the synergies of convergence and divergence of dialogue in a variety of tasks. And so what follows is one such attempt at considering trade-offs in terms of linguistic alignment, using the just described align method. So in thinking about trade-offs, started where I start most things, and that's thinking of how things might change over time. That is, how might the amount of alignment, measured as cosine scores between conversational utterances, progress over a dialogue with certain types of tasks? So let's begin with lexical alignment. Depending on the task, a primary role of lexical alignment, at least early on in an interaction, is to establish localized referential precision, a common way of referring to objects or actions in a task environment. But once a sufficient base of common ground is established, why should it stay elevated? Rather, perhaps lexical alignment is used more strategically and sparsely, and it's the variation of these structures that help move along a conversation. So repeatedly referring to the same elements within the problem space might not be particularly useful. A continuation of high amounts of referential precision via lexical alignment is likely to be taken as overly redundant and unnatural. So one possibility is that some tasks just lend themselves to a general pattern in which lexical alignment would be expected to decrease over time. But does a decrease in lexical alignment mean common ground, a shared understanding? Is it no longer needed? Well, I don't think so, and instead there may be other ways of expressing shared understanding that become more pronounced. And one prime candidate is semantic alignment. So rather than the repetition of the same lexical items, people can instead converge within a semantic space of shared topics and themes without the need for precise lexical repetition. So in other words, more conceptual alignment might supplant the reliance on strict lexical alignment. But then how might one capture non-lexical but conceptual alignment? Well, the Align tool provides a possibility, and it does so by using high-dimensional semantic vector representations of each utterance with Google's deep learning model, Word2Vec. It then uses the same cosine similarity measure as used for lexical and syntactic alignment. So I wish I could get into the details, but please see the Psych Methods paper I mentioned earlier. But the point I'd like to make here is that the measure goes beyond lexical repetition to convergence on localized concepts. So with this sequence of turns, it would seem participants are converging here on a common theme or topic. But if we looked at just lexical alignment, participant B aligning to participant C would show a value of 0, no alignment. Participant A to participant B would also show a value of 0. But if we look at semantic alignment, we now see similarity of one utterance to the previous utterance. And lastly, just for completion of our multi-channel story of alignment, we can make some predictions with syntactic repetition. So what's important here is that we think syntactic alignment decreases over time like lexical, but we speculate that it might be for another reason. We draw on research that shows people are susceptible to reusing the syntactic structures of others when experiencing increased cognitive load. So given the resource efficiency of priming, it's reasonable to suspect that as cognitive demands dissipate, as a task becomes easier, so too should syntactic alignment. So now that I've laid out some of my motivations and speculations, much of this thinking has been the context of one particular project. And so for the last several years, my co-author Cindy DeMello, as well as Val Shute at Florida State, we've been engaged in a large-scale data collection project involving complex collaborative problem-solving interactions. And if dialogue could be described as a synergy between convergence and divergence, if there was a task that could engender the patterns just described in the previous slides, we were seeing it in the interactions we were collecting. So as much as anything else, this work is driven by a curiosity to see whether linguistic alignment could be detected in complex interactions that go beyond simple referential communication tasks to these more creative problem-solving and unrestricted communication. So the basic interaction involves a dynamic game developed by Val Shute and colleagues to support and measure the learning of conceptual physics. Gameplay occurs across multiple levels, freely chosen by teams that are made up of 3 people. They're played over 3 15-minute rounds, and there's lots of different kinds of levels. And in each level, the participants need to get the ball to hit a small balloon. But there are all kinds of obstacles. To get the ball where it needs to go, they need to draw things like ramps, pendulums, springboards, all with their computer mouse, and everything in the environment obeys the laws of physics. An optimal solution, just drawing enough objects to get the job done, earns them a gold trophy. Solving the level but doing it in an elegant way earns them a silver, and a level can end as being unsolved, where they give up and just move to another level. And importantly, in each round, only one person can control the computer mouse, which produces very rich conversations as they attempt to coordinate meeting. So in this task, they must work together to generate creative, sometimes imprecise solutions. There are lots of reference, there's lots of actions one can take. Often multiple possibilities need to be entertained at once and revised to converge on solutions and avoid impasses. So what would linguistic alignment look like in this type of collaborative problem-solving context? Okay, so just before I can get to that answer, just a few things. Not all levels could be used because there was an insufficient number of conversational turns. So we wanted to ensure a reliable signal for examining changes over time. So we only looked at levels with 20 or more turns, and that was 630 levels. The number of utterances, conversational turns, was about 54 on average, and the number of words per utterance about near 11.5. And you can also see, as that one might expect, gold trophies were relatively fewer than silver or unsolved levels. And also teams generally took less time and used fewer utterances when they received a gold trophy. So one of the challenges that we face with the analyses is that when computing turn-by-turn lexical and syntactic alignment, there are a lot of non-occurrences of alignment. So it's highly non-normal with clumping at 0, and then non-zero values that are positive and skewed. So we had to use Hurdle-Gamma mixed effect models that separate each of the alignment variables into 2 processes. One process for the probability of zeros versus non-zeros using a model with a binomial component, and another process for predicting the non-zero values using a model with a gamma component. So in other words, what we can gain from these models comes down to, does alignment at any amount occur, yes or no? And if so, is there a difference in the amount, the continuous variable? And so it's Hurdle-Gamma. And then for semantic alignment, which is not zero inflated, we built models using linear mixed effects. So it should also be mentioned that we entered several covariates that might explain the rate and amount of alignment. Those in blue are ones that were z-scored. Also, given each level had a different number of turns, for each level we also converted turn order into a proportion score based on the total utterances in that level. And this resulted in utterance order being represented as accruing values from 0 to 1. And lastly, random effects for subject and team were entered. All right, so as mentioned, Hurdle-Gamma models generate 2 components, a model with a binomial component and another for non-zero values. Given time constraints, I will focus on the amount of alignment from the model with the gamma component. So that fits the original predictions laid out earlier. And what you see here are the exponentiated estimates showing how a 1 unit change in the predictor causes a multiplicative change in the amounts of lexical alignment. This result of 0.972 can be interpreted in the following way. Going from the beginning to the end of a level, a 1 unit increase, it led to a 2.8% reduction in the mean of lexical alignment. And to visualize the result using a linear effects model, the story here is that lexical alignment starts higher, where the need to establish precise shared terms is particularly important and tends to decrease over time, similar to our prediction. And when looking at the change of semantic alignment over time, we see that this might give way to an increased semantic alignment, as people presumably converge on a shared understanding through shared themes. And for syntactic, focusing just on the amount of alignment, The result of 0.940 here can be interpreted as going from the beginning to the end of a level of 1 unit increase. It led to a 6% reduction in the mean of syntactic alignment. And again, translated with linear mixed effects models for visualization, over time, perhaps as a task gets easier, as cognitive load is reduced, syntactic alignment decreases, similar to our prediction. All right, now something seemingly odd is revealed when we go to predict levels that received gold trophies. So remember, these are the levels where collaborative problem solving could be taken as most successful. For those levels with more semantic alignment, teams were less likely to get a trophy, statistically speaking, below 1. And this opens up an interesting possibility that more semantic alignment is picking up on teams who are overly focused on a single solution, undoubtedly at times the wrong one. So effective collaborative problem solving seems to be more about people exploring the conceptual semantic space more freely, diverse contributions of content and perspective, divergence, which is not tracked by more semantic alignment, but rather less. Okay, so at this point you might be having a strong reaction, but what about... And although our original intuitions about multi-channel alignment were borne out in the analyses, there are many possibilities yet to explore and discuss. And this is preliminary work, and I'm really looking forward to possible suggestions. But taking a step back, I would like to encourage everyone listening to download Align and evaluate your own data with the tool. Being on GitHub, you can make feature requests and help squash any bugs, although there should be few at this point. But a cross-lab effort for a systematic mapping of alignment across tasks with different demand characteristics will give us a more complete picture of the synergies of convergent and divergent functions within communication and dialogue. So I'd like to thank my faculty collaborators who have been involved in some way in data collection and idea inspiration, as well as the students who have helped out tremendously, postdocs in blue, graduate students in green, and undergraduates in orange. Thank you.